My dear friends, welcome to Rajashekhar classes on applied data science with Python. This is lecture number 418. In this lecture, I will continue my discussion on boosting. Before understanding this lecture, I request you to go through my previous lecture, that is lecture number 417. Model of the, what is the model? Model at the end of stage 1 or at first iteration. This is model. Just check that previous lecture where we discussed f1 of x equal to alpha naught h naught of x plus alpha 1 h1 of x at the end of the stage 1, isn't it? Now I will go to stage 2. At stage 2, what I will do, I will again take each of xi. Just let me say, I will again take each of xi. Just model at the end of stage 1. Which one is the model at the end of stage 1? This is the model at the end of stage 1. Now I will go to stage 2. At stage 2, what I will do, I will again take each of xi, each of my xi, and again I will compute error I, isn't it? I already have two models. What are the two models? First model is h naught of x and second model is h1 of x. These are the two models, isn't it? Now I will combine them very ingeniously using alpha naught and alpha 1. Yes, just check it out. What is this alpha naught? Using alpha naught, alpha 1. Now question is, how do you find alpha naught and how do you find alpha naught and alpha 1? That's what it says. How do you find alpha naught, alpha 1? Now your question is how to find alpha naught and alpha 1. We will learn this in next few lectures. We will learn how to compute. We will learn how to compute h naught of x, h1 of x, alpha naught and alpha 1. We will see how to compute alpha naught and alpha 1 in the next few lectures. For now, let's assume in stage 2, what I will do here, my xi remains as xi. My xi remains xi. My error is basically, what is my error? Error is, just check it out, error of I is yi minus f1 of x. We know what is f1 of x, isn't it? Because I have my model at the end of stage 1. What is the model at the end of stage 1? This is my model at the end of stage 1. I have this complex model. What is my complex model? f1 of x equal to alpha naught h naught of x plus alpha 1 h1 of x, isn't it? Which is the sum of two models, isn't it? Is it not sum of two models? We can think of this as weighted sum of two base models. What are those two base models? h naught of x and h1 of x. What are your two base model? You have base model h naught of x and base model h1 of x. Now I will try a model m2. Now I will try a model m2 on this. Let's assume m2 fits h2 of x. Yes, let's try a model m2 on this, and this m2 fits, let me say, h2 of x. Now at the end of stage 2, my final model is my capital F2 equal to alpha naught h naught of x, alpha 1 h1 of x plus alpha 2 h2 of x. This we already got, this we already got this we already got alpha naught h naught x plus alpha 1 h1 x. This we already got from previous stage. Alpha 2 h2 x is new thing, isn't it? What is alpha 2 h2? It's a new thing that I am fitting. If I fit h2 of x, and I will also try to find out the coefficient. I fit h2 of x and I will also try to find its coefficient, isn't it? What is the coefficient? Alpha 2. And so I will keep doing this at the end of stage k. I will keep doing this procedure. If I keep doing this procedure, what happens? Just see, at the end of stage k, what is your model at the end of stage k? Just see, Just see, this is fk of x equal, this is my final model, I equal 0 to k alpha I hi of x. Intuitively speaking, it's a additive model. Is it not? It's an at the end of stage k. This is my final model at the end of stage k. It's an additive model, additive weighted model. I can say additive. This I can say weight additive. It is weighted sum of all base models, isn't it? You are doing weighted sum of all the models. Each of these models is trying to fit the residual error or the error. I can say each of these model or each of these base models is trying to fit the residual error or the error that is left out at the end of previous stage. This is often referred to as residual error. Residue basically means what is left out. Every model hi of x, what is this? Every model hi of x is trained on xi. That is important. Every model hi of x is trained on xi and error i. And error i, isn't it? Every model hi of x is trained on xi and error I, isn't it? Error I, mathematical, I can say error I is residual error at the end of stage I minus 1. Mathematically speaking, residual error at the end of stage I minus 1 is yi minus fi minus 1 of x. This is error of I, isn't it? This is how you kept to train the model. This is how you keep training the model. This is how you keep train the model. And of course, what is right k? K is hyperparameter. K is hyperparameter. We will see how to do hyperparameter tuning, how k changes bias and variance. We will discuss all these things in next few lectures. Our final model fk of x, final model at the end of kth stage is fk of x equal to sigma I equal 0 to k alpha I hi of x. In this case, since I am training each of my model, each of my consecutive models based on the error from previous stage. That is important, isn't it? Each of my consecutive models based on the error from previous stage, this complex model which I have trained fk of x equal to sigma I equal 0 to k alpha hix ends up having, I have trained, let me say I have trained, assume k equal 10. If k equal 10, how many models you will get? I equal to 0 to 10 means 0 to 10, I have trained 11 models in total. If I say, let me say, if I say k equal to 10, what happens? Let me assume k equal to 10, I equal 0 to 10, 0 to 10 means 11 models in total. So at the end of it ends up having low residual error as k increases, isn't it? Ends up having low residual error as k increases. I am fitting to the error. Eventually, my training error reduces because what I am trying to do at every stage, I am trying to keep reducing the error. If you go from fi to fi plus 1 of x, as this I increases, your training error decreases because you are fitting your hi plus 1 of x model, you reduce the error, isn't it? So as training error reduces, your bias on the model also reduces. And what did we want to attempt? Actually, with the whole idea of boosting, as we have base model, just try to recall, this is slide from my previous lecture. What is the whole idea of boosting? We have base models with low variance and high bias, like decision trees which are shallow and whole objective is to, what is the meaning, what we are saying? Let me reiterate this one. What is the whole idea of boosting? We have base models with low variance and high biased, like decision trees which are shallow and whole objective is to reduce bias. and we are reducing bias to training on the error, on the residuals of the previous stage. This is a crux idea of boosting, and how to that this crux idea I already discussed in our previous lecture, isn't it? There are many boosting algorithms. The most there are many boosting algorithms. The most popular, extremely popular algorithm is called gradient boosting decision tree or gradient boosted decision tree. There is other popular algorithm called adaptive boosting. We will see both of them. We will see gradient boosted decision tree, GBDT, that is GBDT, isn't it? In the next few videos we will understand what is GBDT is. It is super duper powerful technique. It's a very very powerful technique across the industry. I have seen tons of applications of GBDT everywhere, especially in internet companies. AdaBoost is also used in some context. Especially it is used. AdaBoost is also used in some context, especially in the context of images. The first very very popular face detection algorithm, where given an image, it has to detect if there is a face and where is the face. If there is a face, it will detect if there is a face and where is the face. It does not say whose face it is. It only detects there is a face. Here very very popular, very very successful face detection algorithm is basically applying AdaBoost on images. Very very popular algorithm. What we will do in this particular lecture series, we will study gradient boost decision tree extensively. We will give a geometric intuition and more applicative intuition of what AdaBoost. Just go through this lecture. If you have any difficulty, please keep a comment. Thank you very much.